Thank you. So, hello everybody. I don't know about you, but I'm the type of person being lazy. I'm a lot of trouble getting up in the morning. Sometimes because I've been drunk the day before, like many of us today. But I want to do the less work I can, if possible. And when you start to write code like that in your application, you have to wonder what the name of that font that you want to put there. And as many of you probably know, you have to put the PostScript name of the font. So you have to open font book and dig to find the proper name. So it's a bit of detective work. It can take a lot of time just to make sure to have the right string there. Same goes for localized strings, where you can find some tedious string to remember what are the keys that you used for that particular localized string. And even if you get it right, maybe you don't remember if that string is used for a format. Maybe you don't remember if you used %d first and %at next, or the other way around. Obviously, I do it wrong every time, so I get a crash at runtime instead of at compile time. So if that code is deep into your application, you have to launch your application, go to the screen, just to realize that it's not working. And that's not the kind of challenge I want to face. So what I want is instead, of course, constants, like this one font family that will list all the fonts, possible font families, and for each font, each variant. Cool stuff about that is that you got autocompletion. Well, when Xcode is not the lazy one, and it's kind enough to work, you have autocompletion. Even if it doesn't work, at compile time, you will get an error if you mistype it. And even for strings, we can go even further, because some strings using formats, we can create constant functions instead of constants that takes the proper type of parameters. So now you have compile time, safety, and strong typing, and that's way better. But that's still a lot of work to do, because if you have to type all those constants by hand, it's still a very boring task to do, and I don't want to type that by hand. So that's why I created SwiftGen, which scans various resources in your project, like fonts, storyboards, strings, assets, and stuff like that. It will scan them and generate constants for you. And the great thing about that is that you just install it in your build phase, for example, once, and then you don't really care about it. It generates the constants every time, especially if you add some strings or some storyboards or scenes in your storyboards or some fonts. The constants will be updated for you. So you have autocompletion, type safety, but also no more manual maintenance, which could be a pain if you have to do that manually. So that's really a great state to be in, because now we have a lot of time to drink more wine and let the compiler do all the stuff for us. But is it enough? I never have enough wine, so I want to have some more time to drink. And we can save more time on other stuff, like this kind of implementation, typically equalable. If you have a struct with 30-ish properties, and you want to implement equalable, doing that by hand can be very tedious. But that's not that's not what SwiftGen would help us with, because that's not a resource like a font or a storyboard. So SwiftGen can't help us with that. So do we still have to type everything and to just continue to type boring code? Let's hope not, because there is a lot of use case, more use cases for that. like when you want to implement some static let all values for your enums. Let's say you have a phone model enum, and in your application you have a UI picker view to let the user choose the model. You will have to have some list of all the models in an array to be used as a data source. But if you do that by hand, and know that we have 3 new iPhones, you will probably forget to update the array. And you will slip into some pitfall that you will be able to avoid if we automate that. So how do we do that? That's the point of sorcery. So sorcery is a different kind of tool than SwiftGen, but they work great in parallel. You can use SwiftGen for resources and sorcery for the code we just saw. And what sorcery does is it scans your code. It creates an internal representation of your code, like the list of all the types that you have in your code. For each type, the name, if it's a struct or an enum. If it's an enum, the list of cases, stuff like that. And with all that meta information, we can tell sorcery to write the code using those information. So for example, for auto cases, we can use that because sorcery scan your code, list all your cases, all your enums, all their cases, and it can generate the code for us. And it could be scary, but it's actually really easy to install. You just download the zip from GitHub, you unzip it, and you add it in your build phase. And with just telling sorcery where to find the sources and the templates, every time you build, it will update the generated file for you. And as you saw here, I've put a lot of template there. For each use case, we want to gain time for boring code, like generating cases or generating equitable implementation. We can create one template for each problem that we want to solve, and each problem that is solved is more nap time or more time to drink wine or whatever, so it continues to save us time. In practice, you might be wondering what a template looks like, because sorcery is all about templates, and if you have to write your own template, it can be a bit scary. But actually, that's not very complicated. Like you can see there, you have a for loop that loops over all your enums, and for each enum, it asks sorcery to write extension, then the name of the enum. So that's a templating engine called Stencil that we use there. You might recognize the syntax for other templating tools, but basically it's just those tags, and using that kind of template, we can now generate our extension like this. Maybe all of this syntax can look a little gibberish for you. I know, but don't worry, I have a classroom this afternoon, as you already know, where we're gonna experiment a lot about that, writing our templates and stuff like that. And SwiftGen and sorcery are well-known tools to generate code, but there is actually another one I want to introduce you. It's Gyro. I don't know if many of you use Realm in the audience, but we do instead of core data. One more skeptical person about core data. So we prefer Realm, but the problem with Realm is to create your own models for the database, your own database schema. You have to write actual code to declare the classes, and so that's not really visual. And we loved about core data, we loved the XData model editor, which is very visual. So we took the XData model that we already had, which is nice because we can move the entities around and define them visually. And Gyro will analyze your XData model and generate code for you from that. And what's cool is that it's now based on templates as well. So you can generate Swift code, but we also have templates to generate Objective-C code and templates to generate Java code, maybe in a future Kotlin code, I don't know. And you can just pick the template that you want, invoke gyro -t and the Swift template, for example, and you'll get the Swift implementation, and same for Java. So if like us at my company, you do a lot of cross-platform projects, you can have one source of truth that is your exit data model, and every platform will have the same model implemented either in Java or Swift for each platform. So that's really cool. And you can also have templates to generate your JSON parsing code if you need that. So that's it for code generation. As you can see, there is a lot of benefits of using it. I don't think there is actually any big drawbacks. So if you're not convinced, just come and see me so I can convince you more. But there is no real drawback and a lot of time saved with those tools. And with all the time saved, you can do whatever you want, but I like to chill, so. So that's it for me, thank you. You can find me on Twitter and GitHub, and all those tools are on GitHub as well. Thank you.
Thank you. Oh, I think your cat just escaped from the backstage. Bad jokes are on us.
Sorry guys, it's late.
Check. Thank you for this talk. It's really interesting also to see that code generation can compensate for lack of reflexivity or things like that, but also in your case with SwiftGen can bring some features that are lacking to the IDE. That's really interesting to see this approach. It's really a clever way to do that.
Yeah. So there are most of these tools are actually here for satisfy a lack of the language of Swift. And things, I mean, as far as we are seeing, are maybe a bit changing, like with Codable. Do you see any other improvements in the future in those fields?
Yeah, actually, me and Christophe created those tools because of the lack of those features, but we see the gap being smaller and smaller because we now have, for example, image literals, so you don't really have the need for constants for image literals. I still prefer them, but for people liking image literals, you can do that. And maybe you know that there is some rumor about equatable and hashable being generated automatically by Swift in future versions, maybe. So that will probably be handled by the compiler as well. So there is already a lot of improvement that we can see in the future, but we don't want to wait for Swift 7 and Xcode 12 to have them. So
yeah, sure. And another question from the crowd is, what's the policy of regenerating the source code files with a SwiftGen or Sorcery if there's no change in the either template but also in the original objects? Will the source will be regenerated every time?
Yeah, well, actually, both Sorcery and SwiftGen have a cache policy integrated in the tool, so we don't regenerate the output if it won't change anything. That allows also Xcode to not see the file as changed even if it hadn't changed. So, and the tools are really fast when they have to regenerate code. Sorcery has been really optimized, even though it has to pass all your code. It's blazing fast. But even in addition to that, there is also caching, so a lot of code is not actually regenerated at each point.
Yeah, it could be seen as the job of the IDE actually to make sure that you have a rule, and if the rule doesn't change, then it will not call your tool.
There are some possibilities with that in build phase. When you configure a build phase in Xcode, you can you can list all the input files, and it will only call the script if the input files are changed. And if the output files are changed, you can list all the output files as well. So it helps Xcode improve the time for those steps.
Yeah.
It's a really misused and misknown feature, but it can be really useful.
Yeah.
To be honest, for sourcery, I never use that feature of input files because every time I add a file to my source, I would have to add that file to the build phase as well. So it's not worth it because sourcery is already super optimized, but it's cool to know that it's possible.
Yeah, yeah. Especially in maybe other cases or for other tools.
Exactly.
So we've seen that we might start having some lots of tools. I mean, like 3-4 tools, like for each project, like Sorcery, SwiftGen, Apollo, or others. How did you manage all those dependencies which are not pods, or maybe with pods or bundler?
Yeah, that's a great question. For all those tools, for libraries, we have pods. For tools like Fastlane, which is written in Ruby, so we have gems. For tools written in Swift, like SwiftLint, SwiftGen, Sorcery, there is no dependency manager yet. So what we use is still Homebrew. We deploy to Homebrew. It's a bit cheating because that's not the main usage of Homebrew, but it works. And we also cheat with CocoaPods because we can actually install SwiftGen and Sorcery as if it was a pod, as if it were a pod. It actually doesn't add any code in your own source code. It's not a real library like any pod would do, but it's just a cheap trick to get the source at the proper version.
Yeah, it just downloads the binary of the tool and put that in some pod dependencies, right?
Exactly. When you run pod install, it downloads the zip and it put that in pods /SwiftGen or Sorcery, but there is only the binary in that folder, no actual source file.
Is that your preferred way?
My preferred way is actually the third one, is to download the zip of the last release and just to unzip that in your repo, so that you're sure you have the binary, even if anyone downloading the source code doesn't know how to use pod or whatever.
All right.
Oh, yeah,
but it's to each their own. There are multiple possibilities to install each tool, and each have drawbacks and advantages, so you can pick your own.
It's true that if you put the binary inside the pod repository, the pod folders, thank you. If you want to commit the pod folder, then you're going to have a binary inside your Git repository, which is not great. So yeah.
Yeah, that's actually the benefits and the drawbacks that I were mentioning. Is that either you commit the binary with your Git, either because you commit the pods, or because you unzip, or but that means that you have a binary inside your Git repo, but that also means that everyone cloning your repo will have the proper version of the tool. You can also install, like I said with Homebrew, you can install the tool system-wide. Then you won't have to duplicate in every project. But if you have multiple projects using different versions, that's a pain to manage.
And you don't know if your colleagues will have the same version as you have.
Exactly.
Oh, okay.
A question from the audience again. Are there any performance impacts with using Sorcery or SwiftGen?
Or performance benefits?
Yeah, that's a really good question. That was a main concern in the beginning when we worked on those tools, and Christophe as well as with Sorcery, because scanning all that and generating all code can indeed take some time, but we optimized it really well. I don't remember all the numbers that Christophe gave us on his last talk about performance, but he actually benchmarked Sorcery, and it was blazing fast. So there is no real impact in compile time. It's in milliseconds, really, the overhead of the compile time. So, and for all the benefits that you get and the time that you save, it's really worth it.
Just the last question that everybody's asking, I guess. Are your slides auto-generated?
I wish.
Thank you very much.
Thank you very much.
Thank you.